All right, so good morning and good afternoon to you all. Thanks for joining our webinar afternoon time in Europe and UK and early morning in North America, where I'm located. So today we'll talk about accelerating aerospace innovation with multidisciplinary design and simulation. Uh, Go to the next slide, Adam, if you don't mind. So I'm Nick Parise. I look after global aerospace and defense activities at Maya. Been at the company for over 20 years. I am an aero engineer, and just some funny anecdotes with hundreds of thousands of miles flown, which would make sense for someone in the aero world, but also as a Canadian based in Canada, spent thousands of hours on a hockey rink. And my colleague Adam, who's our European technical manager, has over 25 years of experience in simulation. He's worked in multiple projects, uh, designed, built, and crashed over 10 radio-controlled planes. I'll reassure you, he's only crashed two. And finally, he's a professional dog walker with his dog, having walked them over 2,000 times. So we're going to be your presenters today. If you go to the next slide, Adam, our agenda for the day is first of all to highlight some of the trends in aerospace and defense engineering, mainly around aircraft design, and some of the challenges all the various aerospace players are facing today. We'll talk about solutions, digital thread for multidisciplinary design and optimization, and notably three key points that we want to get across today around using a single source of truth to manage all of your engineering and manufacturing data, integrating all disciplines in a way they can work together, collaborate, and think of design and simulation tasks as being dynamic, meaning that there's dynamic exchange of information, there's iterative, effective processes, which at the end help you deliver more efficient, higher quality product at a better cost and deliver on time, which is a big challenge in aero. And then we'll close with some thoughts and ideas on how you can get started or continue your digitalization efforts and potential next steps. Throughout the presentation, we encourage you to submit questions via the questions panel at the top right of your GoToMeeting window, and we'll be happy to answer them throughout. Furthermore, we'll have two polls where we're going to solicit and ask for your feedback, which we'll share back with the group on what are some of the main challenges. So that's the intro. Adam and I will go off camera for the next couple of slides and just to kind of encourage flow, but we'll be back on camera at the end of the presentation to wrap up. So just a few words to start on who we are. So we both work for Maya HTT, which is a global company, digitalization company, where we focus on integration of software services, AI, and partner solutions, notably Siemens digital industry software, in this case, to drive digital transformation. We are one of Siemens' largest global partners. And in fact, we've been in the digital business for over 40 years. We have over 250 employees across North America and Europe, and now have over 2 million licenses sold to our clients. So maybe just to take you to the diagram on the right, our three core business activities are around software development. We also offer services around some of these software components, and we resell the software tools in both North America and Europe. Go to the next slide, Adam, please. As mentioned, Siemens is our long-standing global partner. So we've been, really fortunate to have this collaboration with them, both from a technological partnership where we develop over 30 software modules in the Siemens digital industry software portfolio. But in addition, we service and we resell these software tools throughout the globe. So we've delivered over 2,000 services projects in PLM deployments, bespoke software development, AI, and using the data alongside the digital assets that our customers create to get the most out of it. And we're also a very well established aerospace and defense partner globally, where we collaborate with the Siemens teams throughout the globe, mainly because of our experience in A&D, which we'll talk about in a second. Uh, Go to the next slide, Adam, if you don't mind. So just talking about industries, obviously these digital tools are useful to many industries, A&D, industrial machinery, automotive transport, marine energy and utilities, as well as electronics. So we're really well established across industries, but aerospace and defense is our largest industry over the globe, just because of our background as well. Maya being founded originally from a space background. So really taking a lot of our technology coming from worlds that don't have the luxury of building numerous prototypes. Other interesting facts is Maya works directly with 21 out of the 25 world's largest aerospace and defense companies, which is a really interesting fact and really highlights what I was saying around our experience in A&D. Furthermore, other interesting data points: 9 out of 10 top global electronic companies use our solutions, including 4 out of 5 FANG companies, for those of you that know the acronym. And we have thousands of global customers in all these industries. So that's our background, and that's all I wanted to say on that. So if we shift gears to the next slide, Adam, really focusing on uh, the aerospace and defense world and some of the key challenges the industry is facing right now. So really, as the industries is evolving, designing aircraft and spacecraft of the future requires a lot more innovation that we've seen in the past, and with a very important weight on ensuring traceability of all the steps. We see all the regulators keeping a close eye on various aircraft programs, wanting to make sure that there's traceability to see if there is an issue, what happened, where did it happen. So that's definitely a really important trend. And costs are always really important in this field. Delivering programs on time and at the right cost is still a challenge that a lot of aircraft makers are facing. All that with a world where uh, there's more complexity. So folks have to deal with a lot more complexity, which we'll talk about in a few slides. The the challenge is to be creative and rigorous at scale. So basically, aircraft development is defined by multiple complex disciplines having to work together: electronics with mechanical, mechanical with electronics and software. There's a lot more electrification in all the products we deal with today, and Aero is definitely impacted by that. Also, the fact that to be successful, there's many stakeholders involved in a program, notably from an internal point of view, but also all of the supply chain. And that collaboration across teams, across stakeholders is key. And finally, the fact, and that's a historical aero challenge, is a good aero design is always a good compromise solution to multiple objectives. So it's having ways to balance all these multiple objectives, getting to an optimal design that's manufacturable, of course, and adhering to program deadlines. So we're dealing with disconnected data, and any design change will have a drastic impact on costs, quality, and delivery. And just some interesting data points: 56% of companies say, and within their own company, all various engineering disciplines have their own tool sets and systems. So which leads to an internal communication problem, but also with supply chain. And the result of that, and another data point from uh, statistics we get from the industry, is that 45% of product launches in Aero are delayed. And a lot of that has to do with the challenges we're describing here. Go to the next slide, Adam. Just a lot of a slide emphasizing the complexity at various program stages. So at conceptual phase, we'll be looking at tens of designs, maybe simpler designs, but just to do the initial trade-offs where we're dealing with a few hundred of variables that need to be balanced. And as the program matures, we get into a preliminary phase where we converge on one design with 1,000 variables, and as detail is added, going to a detailed phase of the program, we're dealing with tens of thousands of variables over our design. So that balance and that optimization is at the core of the complexity challenge that we're dealing with in the industry. And again, as stated previously, delays in getting these new products into service are the most critical issue affecting the A&D sector, and they carry significant penalties. And a lot of that has to do with dealing with the complexity we're describing. So maybe the question to take us on to the net, the whole purpose of this webinar is, does your ecosystem allow you to explore the deep potential of digitalization? And that's what we're going to explore in the next couple of slides. Go to the next slide, Adam. So how do we bring innovative designs with improved manufacturing and manufacturability and high performance faster to the market? So that's where we really take our partner Siemens's long experience in manufacturing with uh, our experience and their strong experience in digital as well. Go to the next slide, Adam. And really introduce the concept of digital twins. So we'll dwell on that for a second. So instead of speaking about tools, whether they're CAD, CAM, CAE, or AI, we're talking about connected solutions, connected digital threads, each acting in some of the key parts of the design, simulate, and manufacturing process that our aerospace and defense clients have to deal with. So whether we're looking at mission-driven systems engineering, so at a systems engineering point of view, we build a digital mock-up, but we also look at the mission profile to ensure that we meet all of the various mission requirements. Another key digital thread, which is our focus one today, is around taking design simulation tasks and having them work in very tightly integrated, multidisciplinary and optimized fashion. So we'll definitely focus on that. There's also the concept and the thread around smart manufacturing. So how do I take a mature design and ensure that it's manufactured on time, at cost, with the right collaboration, which is the next digital thread on value chain collaboration intelligence, which all has to do with dealing with the supply chain, with suppliers, with other players in the ecosystem around the key OEMs. Uh, Another one that's really important is using these digital tools around verification and certification tasks. So a big challenge and a big element that brings delays in programs has to do with certification. So how are we able to use some of these digital tools to accelerate this verification and certification standpoint? Finally, all that whilst ensuring optimized sustainment and availability, and also looking at model-based acquisition and program pursuit, which is also a big part, of the supply chain collaborations to ensure all parts are available at the right time for a program. So that's the concept of digital twins. And just go to the next slide, Adam. As stated previously, for today's webinar, we're really going to take a deeper dive and give examples around multidisciplinary design and optimization. Next slide, please. So a few more words on some of the key ingredients at making this multidisciplinary design and optimization digital thread successful, and what we're effectively trying to do in practice. First of all, and that's going to be one of our three focus areas. It's important to leverage a single source of truth to break down silos. So really ensuring that at a program level, all stakeholders have access to the data and the latest versions of designs, change notices. So that's definitely one of the key ingredients and solutions at making some of our A&D clients more successful. The second one, which is a classical challenge, but also important, is around integration of mechanical, electrical, electronics, and software disciplines together, and work in collaboration across teams. So making sure that the over-the-wall classical approach is removed, that we really have a really thriving collaborative environment, and that's again achieved by an integrated digital ecosystem that our clients operate with. The third one, is our third focus area for today's presentation, is really looking at dynamic design and iterative processes. So again, ensuring that anytime there's a change, anytime there's an update in design, that all impacted disciplines get that update in a timely fashion and update their work to get to a true integrated concurrent engineering mindset. And we'll also talk throughout on using digital simulation to verify performance. So of course, in the aero world, building prototypes is extremely costly. So how can we maximize usage of these simulation tools to check performance, to even take it to a certification standpoint? And use all of these insights throughout the digital thread that we're talking about to inspire innovation at the end, and ensure that all the cost, the quality challenges that prevail are definitely fixed with some of this technology. So take us to the next slide, Adam. Just a final one that I'm going to cover, saying, well, a lot of these larger global companies have already embarked in this journey. Here we're talking about the Siemens accelerator. So basically the Siemens accelerator tool set, which regroups all of their CAD, CAM, CAE, PLM systems. So really emphasizing that in defense and commercial, power plant makers, electronics in the aero ecosystem, as well as space companies, a very large majority of them have begun this journey, are employing some of these tools to get to a point where they're really accelerating their processes, reducing lead time to delivery. Right. So you can take us to our first poll of the day, Adam. So we're going to take a step back from just us presenting, and we're going to try to get some of your feedback on what are some of the biggest digitalization challenges you're facing. And feel free to respond. You'll see the results live. Are some of your challenges around design, simulation, collaboration? Are they around optimization of product performance, quality, and cost? You also see challenges around managing simulation processes, data collaboration. Another key one is around AI. So everyone, is excited about AI. So what are you doing in this space? What are we doing to take our collective knowledge to make us more efficient? So we'll give people another 30 seconds to submit their polls, and you're all seeing the results live. So you see that a lot of those challenges are common, and frankly, we're happy to see that you're all finding some of these challenges as well in your world. So we'll give this, so the poll has ended. So thank you very much for your responses. So just looking at the result, yes, design and simulation collaboration is a classical challenge. There's a change in design. I want to update any related simulation models and iterate on that. And we can definitely talk about that. Adam will give some examples in a few minutes. We're also seeing that product performance, quality, and cost optimization, when we've talked about the multiple objectives earlier, that's definitely one. And we also see some of you are having challenges managing simulation process and data and collaboration, as well as deploying AI tools. So again, thank you very much for your participation. The goal here is just to share that some of these challenges are common, and we're really keen to work with you to share our knowledge and see how we can help. So at this point, I'm going to switch over to Adam Martin, who will walk you through the multidisciplinary optimization digital thread and really focus on the three elements that I've highlighted before. So Adam, the mic is yours.
Thank you, Nick. All right, so as Nick said, I'll just run through some of these, and I'm hoping to share some examples, get into a bit more detail, which will inspire hopefully some questions and ideas on your side. So the first one is looking at establishing a single source of truth. And we still often find that within organizations we work with, people are operating in silos. The kind of classic is between design and simulation. And that's a key one to address in this thread. These things create duplication, misalignment of versions. Are you working with the right data, for example, and ultimately delays. So it's a key foundational element of that. And so what are the kind of, I guess, the key ingredients or the requirements for that? So we see often that big success comes when people bring together into a single environment the mechanical and electrical software aspects of the design. Having something that's a system that's open can also bring in data from legacy, multi-CAD, for example, and supplier access. These all bring big benefits. But one of the big things for the digital thread is then configuration management. So knowing you're working with the right configuration and doing the analysis on the right thing, and change control. And that's change control across the board here. So design simulation in this case, when we're looking at multidisciplinary design and optimization. So obviously for us, that would be a solution like Teamcenter. So it's kind of the backbone of the digital thread. We're going to be storing all the data and different elements required for the workflows in the digital thread in Teamcenter. It's a unified platform for managing the change. So as I mentioned already, that's an important piece. And we've got the digital mock-up, effectively the designs that are available to us. As you can see from this slide, it's pretty comprehensive what Teamcenter can support. Full life cycle right through to the service and service life of your products. But I'm just going to take a little bit of a deeper dive and look at some of the key enablers for the multidisciplinary optimization digital thread on the next slide. So here we have a few of the kind of highlight areas, and I will be covering these in the examples. That's kind of why I'm introducing them at this stage. So kind of, I guess, at the beginning of most designs is, where there is requirements. And we're capturing those requirements, and we might be starting with systems models, so functional models of our system, and assigning requirements to that, which will be parameters. In Teamcenter, it's pretty open. You can work with something called System Modeling Workbench or Rhapsody or Cameo products, and link those in. And bring your requirements in. And then clearly, for our design, we're going to work with CAD and the configurations and of the different products. And we've got workflow capabilities to manage. This is around the assigning tasks and going through review steps and gates and so on. And a big element of this is also what we call simulation process data management, SPDM. So I guess many of you will be familiar with this technology, but this allows you to, within the Teamcenter environment, to integrate your CAE tools and workflows, build, manage processes, reuse those processes, and capture the meshes and all the load case information, everything around simulation that you would do on designs, and link that back to the original geometry and the requirements that drive that in the first place. So on the theme of integration, let's move to the kind of second key element. Now we've got the foundations in. So that's basically bringing all aspects of design. So this is where we look at the different physical areas that we're working on design for a product, and bring those together, ensuring all the team members are working on the same and the latest data, have visibility of the changes, regardless of which function they are. And you can see on the slide a lot of those examples, and that would include things like electrical design we can bring together with the geometry, and then all the simulation capabilities in these different areas as well. So to illustrate this and how that might work, I've got an example, or first example to show you here. So there's a lot of stuff here, but and I'll talk through kind of each of these steps one by one. But here we're looking at a design process around landing gear design. It typically would involve multiple stakeholders, i.e. multiple engineers working on this. And I'll take you through sort of the product definition, cross-functional product engineering, verification and validation steps, and how that might look in the Teamcenter environment, working as a backbone, and linking that to the various tools to do each of the tasks. The example, it's a reconnaissance drone. It's a kind of demo model that we can use. And it's carrying a camera itself, and we call it the Angel Owl demo. So you can see in the different shots there, the geometry, CAD design. You can see a kind of rendering of what this thing would look like in real life, but also some requirements there and some of the analysis. So we'll follow a process, and it starts with requirements. We'll look at that as the first step. And then from the requirements, we can build a multi-level functional systems model of the drone. And in our case, our landing topology architecture, so how it fits together, has not been defined yet. So we'll take the requirements and use a generative tool to build that topology. So I'll show you a little bit of that. Once the landing gear topology has been defined, we can update our functional model and simulate the system level to make sure all the requirements are met. But also then we can look at failure scenarios and understand which ones would be critical, where we might need to put in redundant systems. And then we can then build out a detailed design of that. So we'll look briefly at that. And we can run multi-parameter optimizations on the chosen topology that we've got. In this example, we'll look at a 3D flexible body motion model, and we can drive that with a technology called HEADS. And once all of this is complete, because we're working in the Teamcenter environment, we can bring all of the changes or all the data back in, and we can update and link that to our requirements. So we can then relate the requirements right down to the detailed model and vice versa. So it's a bit of an example of kind of this integrated design process. So looking at the first step, and I won't spend ages on each of these steps, just want to give you a flavor, and obviously if you've got questions, then we can have follow-ups and deep dives into these in follow-up sessions if there's anything that interests you here. But the first step here is we're looking at a functional model of the drone. So there's several layers, from an operational one to like the detailed, and then right down to the detailed physical architectures. And in the video that you can see playing on the screen, you can see how in this case the functional model is linked and connected and managed within Teamcenter. And we can also then associate requirements and the parameters associated to those requirements in Teamcenter to our functional model. And it's bidirectional, and you get complete traceability. So we can look at a requirement, we can look at the parameter values associated with it, we can navigate to the functional model representation of that, and then later on you'll see how we can link that through to the geometry and the verification and validation simulation or test steps we've carried out with that. So moving to developing topology. So I've included this because I think it's kind of interesting. So in this case, we're using a tool called SimCenter Studio to help us come up with a topology architecture for our landing gear. So we have a set of requirements, we have a set of parameters, and how do we build the best kind of landing gear to meet those requirements and have a performance that meets that. So this is one way of doing it with SimCenter Studio. This is also connected into the backbone, if you like, into Teamcenter. And what's happening in here, and you can see in the videos playing, is it has a whole set of design rules built in there and some systems models, which it can build different architectures for you automatically, combine those different elements together in different ways. and generate some performance data for that to see that it's meeting the design requirements you have. And then we can use what that creates, the architecture of the design that's created here, to inform and build out a detailed 3D model and do further improvement on that. So it's, as you can see, there's some tools to compare different designs as the video runs there. And again, if you want to find out a bit more about this technology and how it works, it's something we can definitely help with. So let's assume we've gone through those steps. We've captured some requirements. We've defined a architecture for our landing gear with all of the pieces. So now we can potentially, or another group might be running some risk simulation scenarios based on the design. This is known as RAMs. So we're looking at things like reliability, the availability, maintainability, and safety of what we're designing. And we create a functional system or functional and logical system design. And then using these tools, we can identify where there's risks in the system, potential failures, and where we might need to build in redundancy, for example. The models are again stored in our Teamcenter environment, which means if there's a change to our system, the use cases, etc., everything is connected, and we can update those models accordingly when we make any changes to requirements, for example. So integrating the safety and reliability. Once we've kind of prepared the geometry from our topology optimization, and we've looked at sort of the reliability of the design, we can do some detailed design work. So we can create detailed validation and then take that into different optimization models. In this case, we're combining a 1D systems model of the landing gear, and you can see on the screen there of how it operates. We're co-simulating that with a 3D model to actually look at the loads. In this particular example, we're looking at the stress loads that are created, and also the response of the control system. Is the gear deploying as we need it to with the speed against the speed requirements? So these can be these requirements parameters can be transferred from Teamcenter to a multi-optimization design tool, in this case HEADS, and we can run an optimization of the simulation model to get best performance and make design changes to meet that. So the middle screenshot shows how we're launching HEADS directly from Teamcenter in this case, and we're feeding our design optimization tool the direct requirements from our environment. So everything's integrated together. And once we generate a design, that can be served back into Teamcenter and managed. And other people involved in the design can see those updates straight away. So final step here that I'm just illustrating is how that would happen in Teamcenter. So here we're looking at our requirements, and the optimized simulation model is then automatically linked back to the initial requirements, and the output and reporting can be generated on it. So, and everyone now can see the status. They can see that the design's being optimized, and the design requirements have been met. So in this example, what I was hoping to illustrate is sort of how this integrated system will allow different users working on different aspects of the design to collaborate, always be working on the latest data. And in this screenshot, you can sort of see how everything's linked together, and you can navigate back from the design to the requirements and vice versa. So wherever you're working within the group, you've got the latest version and you've got visibility of all the key changes. So the final sort of building block, and it's actually really often depends on having the first two blocks in place, is that we can look at leveraging the power of iterative processes and automation. So we saw a little bit of this in the previous example where we looked at the HEADS workflow, but I'm going to dig into this a little bit more deep with some more detail and also show sort of how we can bring in sort of AI machine learning technologies to enhance this even further. So we'll look at a structural example related of our drones. So we're looking at the same drone here, but this time we're going to look at the structural design and how we could capture a workflow to do that, and some of the benefits of that and how that works. So typically, developing a design-based environment for structural engineering of an aircraft involves, comprehensive simulation. You do need to integrate test with this, and we see on the slide here how we would extend into the CAE world for this work. So typically we'd be using something called simulation process data management, which I've touched on before. And this is an open set of tools, so we can bring in our different simulation tools that we're using. We don't have to necessarily use all of the SimCenter Siemens tools here. This is fairly open. We can use third-party tools to integrate. So depending on what you're already using for your CAE analysis in this, we can build up the methods and the tools and capture those within the system. And then we can use SPDM tools to drive those processes and get the level of collaboration that we saw in the previous example. So what might this look like? So I expand this out. So within the system, we can connect the relevant disciplines. So we can launch aerodynamics to get loads, for example. We can do our aeroelastic analysis, structural and stress verification analysis. And we can even bring in here, if we were doing some kind of advanced manufacturing type simulation, we could bring that in. So we can build out our structural workflow and capture that within the Teamcenter and SPDM environment. And then we can start automating steps of that and very efficiently working around the process. And very much like we did with our landing gear piece, we can capture each iteration and the results that are generated at each stage, share that, and revision the designs. And then this lends itself really nicely to automating processes. Now we've got the foundation in place. So I have an example here of a wing design looking at margin of safety based on loads. So we can take our workflow methods, we can place them in a tool like HEADS, and we can automate the workflow. So in this case, we're seeing the CAD model, it's being updated, which updates our mesh, and ultimately we calculate loads and the relevant margins of safety. And this has got huge advantages. Obviously, we can cover a lot of design points very quickly. So for example, if you had 20 variables you were designing, you would vary in this wing design. In each of those variables had 20 values. That's 1 million design points potentially. And you're never obviously going to do that manually. So bringing in these type of tools allows you to explore that design space very efficiently, and you can drive that with what we would call intelligent search tools, which is also part of the HEADS technology. All connected and embeddable within the Teamcenter environment. So there's a little bit more detail on what we're doing in that wing analysis tool. So hopefully the visuals help you kind of understand what's going on. So we've built our workflow. We've captured the different simulation tools required to run the analysis, and then we can bring it into a HEADS process. And what you see on the screen here now is each design point or each point represents a design. The red dots are where the design has exceeded the constraints that we've set in this particular case, which is around margin of safety constraints. And each blue dot shows a design which is okay against the constraints. And the blue line here shows the best design so far. In this case, we're looking for the lowest mass, which meets the design constraints that we've put in place. So you would, if you ran this and you automated process, all of the kind of views that you see would be automatically captured. So then it's very easy to compare and analyze the result sets you've got. So in this case, we were able to reduce the mass of the wing structure against our constraints by 4%, which is, potentially a huge gain in terms of performance. And we can run these iterations very quickly. We can make use of hardware that's available to do that. We can run these things overnight, over the weekend, those kind of things. In this particular case, we did sort of 500 design evaluations and did that in 2 hours. And the tool set has a whole set of post-processing tools to help you sort and rank the different designs you found and pick out what is the optimum against your requirements. And this goes back to the stuff that Nick was talking about here, the complexity in design and balancing all the different design attributes. These tools allow you to do that and do that very efficiently. So once we have a new design, we could potentially capture that and create a new design revision and bring that back for further work and analysis. Another aspect of this is once we've built this foundation, we can start bringing in AI technology. So there's one example here that I wanted to share with you. So here we're kind of working on a drone, but we're doing a CFD analysis in this case. And as you're probably aware, CFD analysis can be time consuming, can take up a significant amount of time. So to repeat a large number of these analysis will take a long wall clock time, even if you'll potentially have the capability to run it in parallel. So in this case, we're kind of using what's called the HEEDS AI simulator predictor. So it's boosting the search. So typically, in the previous example, we saw that we use something called Sherpa technology in HEEDS, which is an optimization algorithm to search for optimum designs. In this particular example, we've enhanced that with this AI predictor. So what it's doing is predicting some of the design points based on the previous ones. And you can sort of see on the chart, again, feasible designs, infeasible, but also AI predicted points. And that will then inform the optimization algorithm, and it will hopefully converge more quickly towards the optimum or the best designs you've got. So again, in this particular case, it reduced the number of actual design simulations you needed to run by 40%. And it gives you a considerable time saving. This is, again, something that's available out of the box within the technology. So, again, if you're interested in finding out a little bit more about this, we can cover this in a lot more detail. So just to wrap up some of the examples that I've shared with you, I have a couple of kind of stories from different Siemens customers, and in some cases customers we've worked with, about how they've deployed some of these type of workflows, digital thread approaches to save time and improve design. So this is a story around by aerospace, and you can see they pretty much used a structural design process similar to the one I outlined previously here. And they were able to use this to validate the structural integrity of design changes in a very quick time, 3-man weeks for them, which meant a lot as they were a small team. And there is a webinar and a lot more details available about this. So if you want to learn a bit more, that is available. And then a couple of other customer references. So I've worked with many clients on these type of technologies and seen some phenomenal savings and performance increases when you go through the building blocks and build up to the point where you can automate processes. So much of this is where people have got to that third stage where they're automating different design processes, bringing in the different disciplines, and you can see some of the numbers. And again, these numbers look good, but they are backed up with reference stories. And again, we can share the links of all of this so you can see the different clients involved in those. Those are stuff that you can find mostly on the Siemens website. And the interesting one, the 30 to 50% reduction in analysis time with automation. So that was Norfolk Grumman that did that. And they were using the HEEDS technology we just looked at quite extensively to do that. And that was also in the space industry. So looking at spacecraft design, that particular example. So with that, I'm going to hand back to Nicholas to take us into a kind of wrap up of the session. So Nick, handing the ball back to you.
Thank you very much, Adam. And that's at the point where we do bring our cameras back up just to interact with you a bit more. I do need to see the slides, Adam. I see your background, unfortunately.
Sorry, yes. Let me manage to kill the slide presentation.
So as Adam brings that slide back up, thank you very much for the attention, and we've gotten some really good questions in the chat window at the same time. Just to summarize the message, right? And I mean, this is I'm going to smile saying that, but this is not rocket science, right? We're going back to fundamentals, collaboration, teams working together, and a digital backbone that favors more efficient data flows between disciplines, between stakeholders. So again, what we've talked about today and some of the keys in deploying a successful multidisciplinary uh, or well, multidisciplinary design and optimization digital thread is to use a single source of truth. So really break down any silos, information being on a server, on a site. No, you bring it all together. And again, using the Siemens digital backbone, Team Center, PLM, that's really an excellent place to start and definitely an area where we can help. We've also talked about collaboration across teams and disciplines. So really making sure that any engineering change, any change in a component gets reflected at all no to all stakeholders that are impacted by that change. So we've talked about processes that can improve by 30 to 50% in terms of execution time, and those are all backed up, and again they are in the industry we work in, so we can definitely again help in this area space. Furthermore, the last thread and the last takeaway is think about design in a broader sense, including engineering and simulation, as being a dynamic world. So making sure that you are able to use simulation and optimization software that makes you more efficient, use some of your historical knowledge as well with AI as well to be more efficient in that process, and make sure again that the overall iterative process is accelerated. Another really great solution for that is process automation, and we've got tools that can help you along those lines. So those to us are the main takeaways of the day. I will ask you to go to the next slide, Adam. Uh, we're just going to run a final poll just to see how we can best help and follow up with you. So really, that's our second poll, where whether you'd like to have a discovery call with us, we're happy to speak to you. Whether you'd like an audit, so that's something we offer, like we can take half a day, walk through your processes with you, provide some recommendations before doing anything further. We can also provide software trials in certain areas. And again, if you don't want to answer on the poll, like by all means, you're free to respond anywhere else. So we will be happy to follow up with you. And in fact, that's the world we operate in. So really give you a few more seconds to fill that out.
Yeah, some feedback's coming in, Nick. I think I'll
Yep.
give it a few more seconds.
Yeah, just give it another 10 seconds. I think we're almost there, Adam.
Yeah.
All right. So thank you all. And again, we will be following up with you. So that concludes the us presenting portion of this webinar. Maybe go to the final slide, Adam,
Yeah,
which is
of
great
course.
because
Yeah.
we still have 10 minutes in case people have questions. So we're at your disposal if anyone wants to ask questions via the chat window that we can treat publicly. This page also offers QR codes to 2 in-person events, one coming up in October in Orlando, Florida, and another one in Coventry, UK, where we will be there with clients, talking about their journeys, their digital journeys. We've seen significant synergies at those events where some of our clients and prospects hear other clients sharing their experiences. So those tend to be really solid user groups, a lot more valuable than us telling you. It's good that you share your experiences between yourselves. So we've got these two events. And the final QR code we've got to the right is to book a discovery call with us. And we'll be happy to follow up with you. So whilst we do that, we did get a few questions along the way
Yep.
in the chat window. I'm probably gonna, you know, go back to
Y-
the Angel Owl example, Adam, and
Yep.
we were getting a question on, how long is the typical process going from requirements to topology to design and analysis? Again, these are clients that we've dealt with part-wise, but we have data. So really their processes, one cycle, we're talking about a few months, right, of going from requirements definition, initial design, some analysis, and circling back. And those are actually a good example of how digital helped reduce that cycle. So the data we have from Siemens and from some of our interactions is in this particular program, they were able to reduce cycle time by about 30 to 40% with digital tools. So that's documented. So that's a really good one to highlight. So that's one question we got earlier. And I'm trying
Nick,
to see if there's, yeah, go ahead, Adam.
there's a bit more of a technical one there about how requirements management is done in Teamcenter and specific tools. So the high level answer is Teamcenter provides a kind of module to do requirements management. There's a lot of options there. But what's really interesting about that, and we see clients get a lot of benefit from, is that those requirements can then be linked to all the other item types within Teamcenter. So obviously you can link that down to geometry, simulation, but verification and validation results are key. So it's built in, if you like, and part of that data and available to everyone. And then it's also available within your change management workflows, etc. There's also a sort of link to that question. There was a question around Cameo, and so there is a possibility to link tools like Cameo to Teamcenter to do your functional modeling, and then you can store and revision those within Teamcenter, and again link them to the requirements. And you can actually link the parameter definitions in, say, a Cameo model to a requirement in Teamcenter and have that two-way link. And so you can track all of that. So again, that's something that came up in the questions, Nick.
Yep.
So,
One new one that just came in. So I see a question around AI tools and what does AI mean from an engineering processes and workflow perspective. So that's a great question. We got challenged. Well, we're all challenged with AI right now in our respective jobs, right? Whether we're using Copilot, ChatGPT, in practice in the engineering world. What Maya's done specifically, we have a very successful industrial AI and engineering AI practice. So some of the examples of how people are deploying AI is, for example, building bespoke, customized, in-house large language models, collecting a lot of their engineering data and practices, best practices, documentation, and making it into something engineers, designers can query to get best practices and procedures at their fingertips in a more efficient fashion. So that's one example. Another example that I'll give in the AI for engineering space is all about building data, right? AI is all around data. So whether it's your legacy background data or whether it's data that you want to use from a predictive standpoint. So I'll use an example on predicting failure of critical parts. The example I'm thinking of is for gas turbines, where they have to deal with cycles all the time. Every time you see planes flying in, landing, unloading people, reloading new passengers, these power plants, these engines stay on for quite a while and do cycle many flights before they go in for maintenance. So a big challenge again is identifying what the maintenance intervals are for these critical parts. So one way you can use some of these digital tools and AI technology to be more efficient is really around using simulation, CAE, to train predictors, to train engines that can then better advise on the maintenance interval. So those are, at a high level, without getting into any specifics, some of the projects that are possible with AI and data in this world. I don't know, Adam, if you care to comment further, but I just wanted to share those insights based on that question.
Yeah, I mean, obviously, I shared a little bit on the AI machine learning approach and enhancing the heats thing. There's also, like you say, reduced order modeling technology, and we're using neural networks to kind of build those reduced order models. So there's a few areas that I can think of which expand on that.
Super. And just looking at questions, I see one more that just came in on how can digital technology help companies improve certification cycle time and process? So that's actually a great question, because certification can be a barrier to project completion for obvious reasons, right? We don't want, just any uncertified, aircraft or spacecraft to fly over our heads. So the authorities do require a pretty stringent and rigorous process. One of the elements that digital can bring is around this requirements management that Adam was talking about. So really having a quick way to show the authorities that for all key performance and safety requirements, that the appropriate checks were made. So that's definitely one of the solutions that we see uh, clients deploy and help them in their certification process. Another one is around some of the tools you use. So some of the CAE tools, notably Nastran, they are certified by the FAA for certain tasks, certain checks. So it's actually another area where we can help with our partners at Siemens to help in some of your certification challenges as well. So just wanted to add that to the conversation here. All right. So Adam, I think that covers it. And in fact, we're right on time with 3 minutes to spare. So we'll thank all of you for your time, the ones in North America that got up early, uh, folks in Europe, joining us over their lunch break. Really thank you for your attention, for your interaction. We got some really good questions, and look forward to following up with you. So with that, organizer, we're going to ask you to close the webinar.